So, how does a closed drain system work? As highlighted before, the main driving force for drainage is gravity. That's why the drainage point in the system is at the lowest point. In addition, the drain lines are sloped downwards to ensure free drainage of the trapped liquid to the drain system. So, for a vessel that is expected to collect all the liquid from the plant, it should be at an elevation that is less than any drainage point. That's why it's common for a closed drain vessel to be located underground. So in this case, we may have many equipment or systems in the plant from which we need to drain the remaining trapped volume. And we are having a vessel to collect the drain from all sources. This vessel should be at the lowest point in order to ensure proper drainage and evacuation of liquids from the plant. After draining the fluids to the vessel, level accumulates inside. That's why there would be a pump. Note that the vessel is below the grade level, so the pump would even be lower, which may be a civil consideration as we may need to dig further in the ground. That's why this pump is either a submersible pump in the vessel or a vertical can pump. Of course, needless to say that this pump should be positioned below the lowest liquid level in the vessel in order to avoid the pump cavitation. Now, we should know the final destination of the fluid. If we are talking about a precious fluid that we don't want to lose and we want to recycle it back to the process, then most probably it shall have its dedicated drain system. If it is a mixture of fluids that can't be used further, then we should know where we shall send this fluid, or maybe we can use it as a fuel for the fired heater, for example. So, depending on the fluid to be drained, we should know its final destination. Sometimes we may even need more than one closed drain vessel in the plant, depending on the nature of the fluid. For example, if the fluid is valuable and we can use it again, or if the fluid is highly corrosive, we may need special material for the drain vessel. This means that instead of specifying an expensive material for a large drain vessel, we can limit this to a small vessel and consider another vessel for the other liquids. One of these examples is the drainage of the amine solvent. Also, there may be some light ends in the fluid, which means that vapors shall also accumulate and pressure in the vessel may rise. That's why a vent should be considered in this case. If we are sure that these vapors are not harmful, then the vent can be to the atmosphere at a suitable height, which is the safe location. Safe location is usually calculated using dispersion calculations to ensure that this vent won't harm the environment or harm personnel. In many cases, the drain system is connected to the flare. However, we should take care that the flare exerts a back pressure on the vessel, which means that the drain vessel shall be operating under a slight pressure. The back pressure may be even higher in the case that there is some emergency relief load on the flare. The pressure should be considered when designing the vessel in order not to impede the flow on the drained fluid to the vessel. In these cases, the use of nitrogen to prepare the system to be drained and help push the drained fluid to overcome the back pressure may be considered. But what about temperature? Although the system is depressurized, it can be drained at the current operating temperature. So, in most cases, a closed drain vessel should consider a high temperature. This means that the design temperature of the vessel should be the highest operating temperature among the drain systems so that the vessel can mechanically withstand it. If for some reason the vessel is not designed to withstand this temperature, then the operator shouldn't drain the system until the fluid is cooled down. Sometimes even it may be mandatory if we are expecting to serve a fluid with a high pour point. and if we are waiting until the temperature is ambient, it won't be very viscous or it may solidify in this case. So in this case, we shall need to maintain the temperature of the closed drained vessel at a high temperature due to the high pour point, for example. Then the vessel should be equipped with a heating coil, and of course this coil should be below the lowest level of the vessel in order to avoid the overheating of the coil.